Okay guys, so today we're going to be looking at, we're still on the topic of differentiation. We're going to be looking specifically at the chain rule, right? So this is the chain rule here that I have written down. Now before we get into the formula, we have to note that the chain rule is used to differentiate an expression that you have in a bracket raised to some power, right? So for example, like we have this one here, 5x plus 1 in brackets raised to the power 3, right? So once you have some expression and it's in brackets and raised to a power, we normally apply the chain rule. So now let's kind of go into the formula. So we have dy dx is equal to dy dt multiplied by dt dx. Okay, so I'm going to show you where this dy dt and this dt dx coming from, right? It's not difficult, and you're going to realize that when we do this example, right? So we have this expression raised to a power. The first thing you're going to do is get a substitution. So you're going to let t equal to something, right? Normally you would let the substitution be the expression you have in the bracket, right? So in the bracket we have this here, which is 5x plus 1. We're going to let t be that. So that's the first thing I'm going to write. Let t equal to the stuff in bracket, which is 5x plus 1. Right? No magic there as yet. Okay. Next thing we're going to do is differentiate this here. Now you remember before when we was differentiating, right? It would be y equal to something it was differentiating. So when you differentiated, we would write dy dx. Now because it's t you're differentiating, instead of putting dy, we would put dt, because t is what you're differentiating, and we're differentiating with respect to x, so you put dx underneath. Right? So no magic yet. Simple stuff. So we're going to differentiate this here. If we have 5x, we know if we have a constant and just x, we'll just get back the constant alone, right? So 5x, when you differentiate that, we're going to get 5. And we know if we have a constant by itself and we differentiate it, we're going to get 0. So we're just going to get 5 for the answer here, right? So notice in your formula, you had dt dx, right? So kind of like we done get this part already. So we need to work on this part. Now the next thing you're doing is we're going to write over this. I remember we were letting t equal to the part in the bracket. We're going to write over this in terms of t. So anyway, I see 5x plus 1, I'm going to write in t. So I'm going to take off this and put in a t here. So I'm going to get y is equal, you remember instead of this, we're going to put t power 3. Right? Good. Now we're going to differentiate this. So it's y we're differentiating, so we put in dy d. Now we can't put dx because it's not x we have here. We have to put dt because we're differentiating the t's. And just like how we learned to differentiate the x's, we're going to differentiate this t, right? So normally we pull the power in front, t squared. Good so far, right? Okay. Now we have now we have dy dt, which is this, and we have dt dx. So we're going to write down our formula. So the formula is dy dx is equal to dy dt multiplied by dt dx. Alright, we're going to plug in all the parts we have. So dy dt is this. dt dx is 5. Right, so I'm going to work out this. So I would get 5 3s are 15 t squared, right? But you remember that the initial question that we started with didn't have any t in it, right? It had x in it. So now we have to go and put in back what a t means, right? So t means this, so we can just put back in t here, right? So the real answer would be, so just replacing the t with this here. So you have 15 by 5x plus 1, right? So 15t, and you put back here square sign. Let's write that properly. And that's a dy dx. Easier, right? Okay, so I'll show you a next example, And then there's a shortcut to doing it. Now, depending on how the question come, you have to know if you could use the shortcut. If it's a multiple choice, go ahead and use the shortcut. If all they asked you to do was differentiate this, obviously you had to put in all the work in. Right? So I'll show you the shortcut in a time, but let's do a second example first. Okay, so this is our second example. So we're going to try to differentiate this, right? So the first thing we have to do, again, like the last question, was put in our well, you're putting your substitution, right? But for this question, sorry about that. Let's just start over. For this question, the first thing you would do would not be putting your substitution. Now, just by looking at the question, right? What you notice is that we said if we could use the chain rule if we have some brackets with a power. But notice this is a fraction question. So the first thing we will do is change it to just some ordinary fraction with a power, and then we would go from there, right? So we know if we have a power and anytime we want to bring it on top, it will just be the same power but with a negative sign. So we're going to write it over. So this could be written as 2x squared plus 1 to the negative 3, right? So we have some expression raised to our power. So we good. Now we could actually get into the question better. All right. Let's start with the substitution. Again, the substitution is this part that we have in the bracket. So we're going to let t equal to 2x squared plus 1. Then you're going to differentiate t. So it's going to be dt dx is equal to, we're going to differentiate this. 2 2s are 4. We're reducing this by 1, so it come like 1. You can leave out the 1 if you want. And this part here will change to 0, so we leave all that. Right? Then we're going to write over this in terms of t. So that means that y is equal to t to the power minus 3. We go and we differentiate this. dy dt. We pull the negative 3 in front. Now, up here we have to reduce this by 1. Negative 3, take away 1 is negative 4. So on top here would be negative 4. Then we're going to apply our formula. So I'm going to write down the formula. Same formula we did. dy dx is equal to dy dt times dt dx. Right? So we're going to plug in the different parts. Okay, so dy dt is this here. So we're negative 3t to the minus 4 times dt dx is this one here. So we get 4x. 4 3s are 12. Negative by positive will give you a negative. T by x is tx, so okay, I'll bring the x first. So it'll be 12x t to the power minus 4. Alright, because remember I have the x as well. So we're gonna substitute back t. You remember t is 2x squared plus 1. We're gonna just stick in back that here. So 12x, remember we're sticking t there, right? It's 2x squared plus 1 to the power minus 4. If you want, you can leave your answer like this. So if you want to see this as positive, you remember you could throw it underneath. So if you want to put that underneath, you could also write it as, remember it's only the bracket that is raised to this power, right? So underneath, only the bracket will go. Positive 4. And that's it. Okay, so in order to do the shortcut, notice I used, for the first two examples, I used back the same two questions that we had before. And then I have a third example here, right? So let me just do the first two and then we get into the third one. Right, so obviously a shortcut need to be short, right? The first thing is you want to make sure it returns with the expression to the power. So like this one, you know, we had some extra work to get it to just the expression written with its power on top. Right? But this one good, so we don't have to do that. Alright. This is how simple it is. So dy dx. Make sure the C in properly here. Right. So dy dx is basically, right, what you're going to do, you're going to take this 3, pull it to the front of the whole bracket, right back where you have in your bracket, reduce this by 2. And then you put in the next bracket and you're going to differentiate what you have inside here. If you differentiate this, you're going to get 5. And then you just simplify your answer. 5 by 3 is 15. 5x plus 1 squared. Alright, so I'm going to go over that again. It's, you're pulling the 3 in front. You're reducing the power by 1. So you pull the 3 in front, right back what you have in your bracket, reduce the power by 1, you're going to get 2. Then now you differentiate inside the bracket. You get 5. Right? So let's do it with this one. So before we could actually do this, we had to write it like this, right? So we're going to do number 2 now. We're going to try to write it like this. So we would write 2x squared plus 1 raised to the power negative 3. Right. What we're going to do is we're going to take our negative 3, bring it in front. Right back what we have in our bracket. Reduce this by 1, you'll get negative 4. And then you put our next bracket. And you're going to differentiate inside here. So 2 2s are 4x. Right? When you're done, you just kind of, you try to clean it up. So what basically you're doing is multiplying this and this. So 4 3s are 12. Negative 12x. And you're going to get, pull back your bracket. Raise to negative 4. Now, as a shortcut method, if you do understand the shortcut method, just stick with the long way, right? But this is, it's nice if you understand it for multiple choice. You could save a lot of time. All right, so we're going to do this one now. This one looking a little different. But we know square root as a power is to the power half. So we're going to write that first. So this will be 1 over x plus 4 to the power half. Right? But we know we could only use this rule if we had that power on top. So we're going to fix that now. So y would be equal to x plus 4. If we bring that on top, it's negative a half. Now let's use our rules. We're going to use the shortcut. If you do want, you can use the long way. So dy dx is equal to, so we're going to bring this negative half in front. If you will write it in our bracket, you don't write it in our bracket, it's up to you. So negative a half. We're going to write what we have in bracket. Reduce your power by 1. So negative a half. Take away 1 is negative 3 over 2. You can check on your calculator if you want. And then for the next bracket, you have to differentiate here. And if we differentiate here, we're going to get 1. So we fix that. Remember, you're just times in this bracket and this bracket, right? So half by 1, that wouldn't change. Okay, let me write the answer down here. So it will be negative a half by x plus 4 to the power minus 3 over 2. And you're done. Okay, so I hope you guys understand it. If you have any questions, please ask. Like I say, if you don't understand the shortcut, you could use the longer method. It's not a problem. Okay.